Can you see my representation?
Yes.
Yes, okay. It's me, George Dawood, and my project was about the global weed head detection. Its aims is to detect wheat heads from images like the image is at the right. A wheat head is defined as spikes at the top of wheat plants that contains grain. Why is this important? This is important because wheat is a strategic crop in Canada, as Canada ranks third over the world in wheat exporting, and about 90% of this wheat is coming from prairie provinces. So, estimating the density of wheat heads not only help in estimating the profit or determining the well-adapted wheat species, but also can be used to determines the area infected with worm. Worms is a serious problem in peerless preferences as it's harder to be detected. It is underground, but it feeds on seeds, so it results in weak, thin plants and less production. That is the reason that University of Saskatchewan and 8 other research institutes located at 7 countries distributed in 4 continents has developed a data set of more than 4,000 annotated images of wheat heads. This was published as a competition on Kaggle 8 months ago. Because this geographic distribution, this image has a lot of challenges like different lighting, self-occlusion, and also some of them contains some irrelevant objects, have different species and different maturity phases. This is an example of samples from this dataset, and you can see there is a varieties in the image, in the background, in the lighting, and in the maturity status itself. Also, the image at the middle have irrelevant object, the man standing here, and some of this image doesn't include any weeds at all. Related works, this problem has been addressed by a lot of papers, some of them using traditional methods like linear support vector machine over a safe descriptor, other uses morphological operations, other try to use a shallow neural network trained upon wavelet transform coefficient of that image. Binary search is also tested over a statistical model of the image, but the result was less accurate and required a controlled environment, so those cannot be applied to our data set. Recent papers try to add deep neural network approaches like RCNN, GoogleNet, and the YOLO version 4 and faster RCNN. And they have accuracy of more than 90%. Our project will investigate 3 deep neural network architecture and determine which is the best for them to solve this problem. These architecture are YOLO version 3, YOLO version 4, and faster RCNN. Why this architecture? Because they can be considered the last compatible version of their kind. Although YOLO version 4 is called YOLO, but there is a debate, is it a YOLO or not, because it adapted different features than other YOLOs. Faster RCN is not its last version of this kind, but the last is masked RCN, and masked RCN required a masked binary image for each object, which is not available. So faster RCN is the last compatible version of its kind. Here is a brief comparison between the 3 architectures. YOLO starts first by classification of the object and then try to find a bounding box around this object. I treated this problem in a regression kind problem. But fast RCNN using an opposite approach, it first locate the object, locate the box position, and then doing the classification. All the 3 architectures using multi-scale approach to reduce the bias toward the boxes size in the training set. Also, they are using anchor boxes, which first introduced by fast RCNN. YOLO version 4 added more features to YOLO version 3. These features are called bag of specials, like special pyramid pooling. These features increase the prediction accuracy and add less computation cost to the prediction itself, it is also adapted to work well on GPU. I divided my dataset into two parts: 70% for training and 30 for testing. And here is the testing result over multiple IOU threshold. This is the mean average precision. And as you can see, the faster RCNN gives a high score than both YOLO 3 and YOLO 4, but YOLO 4 is more close to faster RCNN. And here is some result from the prediction I got. I'll show to you eight samples. Each side will have two, and the detection with different architecture of these wheat heads. In this image, you can see that there are a white box which represent the ground truth, and there is a box in another color which represent the predicted value. I choose these figures because there are some notes in it, like in this wheat head, there is no annotation, so this missed the annotation. So even it is correctly detected as a wheat head, but it calculated as a false detection because there is an error in annotation. Um, uh, Also, you can see that the predicted are more accurate than the actual annotation. Here's another example there's another example of our result, and you can see this wheat is handled as two objects instead of one object. This is a problem here, and there is a missing prediction in YOLO 3 and in faster RCNN, which is detected in YOLO 4. Here is another example, and I also can notice that at the bottom of the first example, there is a parts of wheat, small parts of wheat that are not annotated, and it was detected by YOLO version 3 and YOLO version 4, so that it is counted as a false prediction, although it is not predicted by fast RCNN, maybe because faster CNN has been trained to neglect small objects at the edge. Also, there are two objects here, as I can show to you by my pointer, two objects too close to each other, so is predicted as one object. This happened in all architectures. In the second example, very small objects are not detected. Uh, this is another problem. Here is two good examples. In this examples, the first show a large dense prediction, and the second show a low dense prediction. For the conclusion, all the architecture performs well in solving the problem of wheat head detection, but fast RCNN has the highest detection score, and YOLO version 3 has the lowest, and YOLO version 4 has a close one to faster RCNN. The performance is reduced because of three major problems. First, failing to detect very small heads. Two, mistakes in the ground truth. Three, combining close heads into one object, as I showed to you in the examples. Uh, Thank you for your patience. And after I show you a demo, I'm be happy to receive your questions. Uh, Here is my code. I use Google Colab to take advantage of its GPU. It read the images from Google Drive, my Google Drive, and store images and store the result in a Google Drive. I run first YOLO version 3, and as you can see, it will take a list of images and produce and produce an output file, a text file containing the region of interest, and then this file is being parsed, and the output is generated. If I run this, it will take some time, but There is some warning at the beginning because of a conflict between the Colab environment and the YOLO. Then the YOLO configuration is loaded, and also the weight is loaded. Now it is done. It is doing the prediction, and after that, the result start to appear. Yeah, just a second. It takes a long time at the first. Sorry, there's a missing import here. Okay, I'll try to run. Okay, there is a problem here. Just a second. Now the prediction is created, and it shall be put in this folder. When I refresh it, there is a prediction, and as you can see, this is the figures using YOLO version 3. And if I close this and go to another folder, which is for YOLO version 4, it is empty now. But when I run its code, it will be the same, uh, uh, as it will be trained, and it will be predicted, and the region of interest will be saved in a text file. Then this text file is parsed, and the output will be produced. Uh, and now the output is produced, and the output will be put here in this folder. If I refresh it, it may take another time. Okay, there is a result start to appear. Yeah, it wants more refresh, but there is a result of using YOLO version 4. And for faster RCNN, this is a code for faster CNN, and also the result will be inserted in another folder, which is empty at the first. And now the prediction is generated, and it will appear in the folder like after a couple of refresh, like this.